Hello there, and welcome back to Sleepy Space. Tonight, we'll step softly into one of the greatest mysteries ever pondered: what existed before the Big Bang. For as long as humans have looked up at the stars, we've wondered not only how the universe began, but also what, if anything, came before it. It's a question that pulls us to the very edge of what we can know, where science meets imagination and the cosmos feels endless. So find a comfortable place, let your thoughts settle, and let's drift together into this vast mystery. To begin, we have to imagine the moment of the Big Bang itself. About 13.8 billion years ago, all of space, time, energy, and matter erupted from a single, unimaginably dense and hot point. This wasn't an explosion into space, it was the sudden creation of space itself. In that instant, the rules of physics as we know them took shape, and the universe began to expand. But here's the haunting question. If time and space themselves were born at that moment, what does it even mean to ask what was before? For many scientists, the Big Bang isn't just the beginning of everything we see around us. It is the beginning of time itself. According to general relativity, asking what happened before the Big Bang is like asking what's north of the North Pole. The question seems to dissolve because the very concept of before may not exist without time. Yet despite that, human curiosity is stubborn. We still wonder, we still ask. And science, with all its imagination and rigor, has offered several breathtaking possibilities. One idea suggests that the universe never truly had a beginning at all, that it has always existed in some form, cycling endlessly through expansions and contractions. This is known as the cyclic universe model. Imagine the cosmos as a vast heartbeat, expanding, slowing, collapsing back in on itself, and then expanding again. If that's the case, the Big Bang we know may have simply been the latest beat in an eternal rhythm, one of countless before it. Another possibility lies in the strange and mysterious realm of quantum mechanics. At scales far smaller than atoms, the universe becomes a frothing sea of uncertainty, where particles appear and vanish in the blink of an eye. Some physicists suggest that the Big Bang could have emerged from a quantum fluctuation, a sudden, spontaneous event from an underlying quantum vacuum. To us, a vacuum sounds like nothingness, but in physics, it is a restless field of energy, always bubbling with potential. From that restless sea, a universe could have sparked into being. And then there is the idea of the multiverse, a concept as thrilling as it is unsettling. What if our universe is only one bubble in an infinite cosmic foam, each bubble with its own laws, its own galaxies, its own history? In this view, the Big Bang wasn't the birth of everything, but only the birth of our universe, one among countless others, forever emerging in an endless cosmic sea. These are only glimpses, only possibilities. Yet even entertaining them stretches the imagination farther than it was ever meant to go. Some scientists suggest that the very concept of before may not make sense in the way we usually think about it. Time itself, according to Einstein's theory of relativity, is not separate from space, but woven together with it into a single fabric called spacetime. If the Big Bang was the birth of spacetime, then asking what came before is like asking what lies outside the edge of all edges. There is no before in the traditional sense because time itself had a beginning at that moment. Still, there are theories that attempt to peer beyond this boundary. One of these is the idea of a timeless state, a realm where the usual rules of time did not apply. Imagine a reality where nothing changes, where no second follows another, where existence simply is. From such a timeless state, the Big Bang may have marked the first event, the first moment where change occurred, creating the flow of time we now experience. Others propose that our universe could be part of a grander structure, a cosmic landscape where universes are born and fade away like sparks from a fire. This idea often goes hand in hand with the theory of eternal inflation. According to this picture, the universe began with a rapid expansion called inflation, but inflation itself may never have truly ended. Instead, while our patch of the cosmos slowed down and became the universe we know, other regions continued to expand, giving birth to countless bubble universes. Ours is only one of them. Another possibility comes from the strange but fascinating idea of a bounce. Instead of beginning from nothing, our universe may have emerged from the collapse of a previous universe. Imagine a vast cosmos contracting under its own gravity until it could shrink no more, then rebounding in a colossal burst that we now call the Big Bang. In this view, the Big Bang was not the beginning but a transition, one bounce in an eternal cycle of contraction and rebirth. There are even ideas from string theory that suggest our universe could have been born from the collision of vast, higher-dimensional objects called brains. In this scenario, the Big Bang wasn't an explosion of nothing into something, but the fiery aftermath of two immense cosmic sheets colliding, releasing the energy that became our universe. Each of these possibilities opens the mind to a vision of reality far larger than our day-to-day experience. They challenge the way we think about beginnings, endings, and the nature of time itself. And while no one yet knows which, if any, of these ideas is true, each brings us a little closer to understanding the deepest mystery of all. There is also the haunting possibility that nothing existed at all before the Big Bang, not even a void. In this view, the universe truly began from absolute nothingness, no space, no time, no matter, no energy. But this raises one of the hardest questions ever asked. How can something emerge from nothing? Some physicists argue that in the quantum realm, the laws of physics may allow such a transition. Nothing, in the scientific sense, may not be the absolute emptiness we imagine, but a kind of unstable state with the potential to give rise to everything. To picture this, think of a perfectly calm, featureless lake. It looks still, but beneath the surface, currents swirl invisibly. The slightest disturbance could create ripples that spread across the entire surface. In the same way, what we call nothing may actually have been a restless field of potential, waiting for the tiniest fluctuation to ignite the cosmos. That tiny spark, magnified in an instant, could have unleashed all the energy and matter that became our universe. Another perspective comes from the idea that the Big Bang might not be the only beginning. Some scientists suggest that universes can bud off from one another, like branches growing from a cosmic tree. In this vision, our universe could be the child of a parent universe, born through a process we barely understand. If that's true, then asking what came before is like asking about a family tree without end, each universe linked to another, stretching backward beyond imagination. What makes these ideas so extraordinary is that they stretch the limits of what human minds can grasp. We are creatures bound to time, living moment to moment, measuring our lives in days and years. To think about a reality with no time at all, or about universes branching endlessly, is to stand on the edge of comprehension, looking out at an ocean of mystery. And yet, even as the questions multiply, the search itself is what brings us closer to understanding our place in the cosmos. Some researchers turn to the concept of quantum cosmology, where the entire universe is described by the strange rules of quantum mechanics. In this framework, the universe may not have had a sharp beginning, but rather a smooth emergence, like a dawn slowly brightening rather than a light switch suddenly flicking on. Stephen Hawking once suggested that asking what came before the Big Bang is meaningless because, in the quantum view, time could behave more like a curved surface than a straight line. Just as there is no edge to the surface of a sphere, there may have been no before the Big Bang. Time itself might curve back into the universe, with no boundary where a before could exist. Another mind-bending idea is the multiverse theory. Imagine countless universes, each with its own laws of physics, bubbling into existence in a vast, unseen expanse. Our universe, with its stars, galaxies, and life, would then be just one bubble among many. In such a vision, the Big Bang was not the first event ever, but simply the local beginning of our particular bubble, while others may have begun long before and continue to emerge even now. And yet, with all these theories, we still face a profound silence. None of them fully answer why there is something instead of nothing, why the laws of physics themselves exist, or why our universe is capable of supporting life. These are mysteries that may forever stay just beyond our reach, like stars seen faintly on the horizon but never touched. The beauty of this search lies not in the certainty of answers, but in the depth of the questions. Each possibility, whether it speaks of cycles, collisions, quantum fluctuations, or infinite multiverses, is a reminder that the story of the universe may be far grander than we can ever imagine. Another perspective comes from the concept of vacuum fluctuations. In quantum physics, even what we call empty space is never truly empty. It seethes with temporary bursts of energy, where particles and antiparticles flicker into existence and then vanish almost instantly. Some scientists believe that our entire universe could have sprung from such a fluctuation. In this picture, the Big Bang wasn't a singular miraculous event, but the natural outcome of the restless quantum vacuum giving rise to space, time, and energy. This idea is tied closely to the concept of quantum tunneling, where events that seem impossible can still occur given enough time. The universe itself may have tunneled into being, slipping through the barriers of nothingness into existence. If so, then before the Big Bang, there was not nothing in the absolute sense, but a fertile sea of quantum potential, waiting to blossom into a cosmos. Others suggest that what we call the beginning might instead be an eternal process. The universe could be without a first moment, endlessly stretching in both directions of time. In this view, the Big Bang was simply a phase transition, a dramatic change from one state to another, but not the first state ever. Just as water can freeze into ice or boil into steam, the cosmos may have shifted from one form of existence into another, with no true beginning at all. Each of these theories challenges the boundaries of human thought. They push us to imagine realities where time itself is not fixed, where the universe might cycle endlessly, or where creation is born from fluctuations in a field we cannot see. And though none of them give us a final, undeniable answer, together they paint a picture of existence as something far richer and more mysterious than the human mind can easily contain. There are also theories rooted in the concept of cosmic cycles. According to these, the universe is not a one-time event, but part of an infinite rhythm of expansion and contraction. After expanding for billions of years, the universe could one day slow, collapse back in on itself, and trigger another Big Bang, giving rise to a new cosmos. In this endless dance, the question of what came before becomes less about a singular moment and more about the ongoing heartbeat of existence itself. Some versions of this idea suggest that traces of previous universes might still linger faintly in our own, hidden in the cosmic microwave background or the distribution of galaxies. If ever discovered, such evidence could mean that our universe carries the echoes of countless predecessors, each one shaping the next in ways we are only beginning to imagine. Other models go further, suggesting that different universes may not come one after the other but exist side by side. In these multiverse scenarios, Our Big Bang was simply the opening act of our particular universe, while countless others remain forever beyond our horizon. If true, then the question shifts again. Not just what came before, but how many realities might exist alongside our own, invisible yet real. It is a humbling thought that what we see as the entirety of creation might be just a single thread in a far greater cosmic tapestry, woven from beginnings and endings that stretch beyond anything we can measure or fully understand. Some scientists even propose that time itself may have emerged along with the universe, meaning the phrase "before the Big Bang" could have no real meaning. If time had no existence until the universe began, then asking what came before is like asking what lies north of the North Pole. In this view, the Big Bang wasn't an explosion inside time, but the very moment time itself came into being. This idea can feel disorienting because our minds are wired to think in terms of causes and effects, beginnings and endings. Yet if time itself was born with the universe, then the Big Bang wasn't caused by something earlier. It simply was the starting point, the boundary where questions about before no longer apply. Another intriguing possibility is that the laws of physics themselves evolved. Some researchers suggest that universes may arise with different physical rules, and those that can sustain stability and complexity survive, while others fade quickly. If that is true, then our universe is the product of a vast cosmic lottery, one in which countless attempts have been made, but only a few lead to galaxies, stars, planets, and life. In all these theories, whether they speak of quantum fluctuations, cosmic cycles, or the birth of time itself, one truth emerges. The universe is far more mysterious and profound than our everyday senses allow us to see. And perhaps the greatest mystery of all is not just how it began, but why anything exists at all. Philosophers and physicists alike often reflect on that ultimate question: why is there something rather than nothing? Some argue that nothingness itself may be unstable, unable to truly exist. If absolute nothing is impossible, then the existence of something, even a universe, might be inevitable. In that sense, the Big Bang wasn't a rare chance but the natural unfolding of reality. Others look toward the idea of higher dimensions, realms beyond the three of space and one of time that we know. In certain models, our universe could be like a bubble or a membrane floating within a larger dimensional space. The collision of two such membranes could ignite the energy we see as a Big Bang. If so, then before our universe, there may have been an entire landscape of other structures, with their own mysterious properties and histories. These ideas are difficult to test, yet they give us a way to think about a beginning that may not have been the first, a creation story that is only one chapter in an infinite book. Every possibility deepens the mystery, and yet also adds to the wonder, reminding us that even the very act of asking these questions places us within a universe capable of contemplating its own origins. So, what existed before the Big Bang? The truth may forever remain hidden, but in seeking the answer, we discover something just as valuable: a deeper connection to the vastness of existence itself. And still, new theories continue to emerge, each offering a fresh perspective on the question. Some scientists suggest the Big Bang may not have been a singular beginning at all, but instead a bounce, a transition from a prior collapsing universe into the expanding one we inhabit today. In this scenario, the cosmos never truly began or ended, but has always existed in a cycle of birth, growth, collapse, and rebirth. Others envision a universe that sprouted from a multiversal landscape, where countless other universes are continuously forming. In that picture, our Big Bang was just one bubble in an endless sea of bubbles, each with its own laws of physics, its own dimensions, and its own mysteries. The conditions that allowed for galaxies, stars, and eventually life may be rare, yet within the infinity of universes, perhaps inevitable. And there is also the idea that the universe may have been born from pure mathematics itself. Some thinkers propose that reality at its core is not physical but mathematical, with the equations and patterns that govern existence existing timelessly, independent of space and matter. From that timeless realm, our universe could have unfolded like a story written long before it was read. Each theory is like a window into a truth just beyond our reach. And though we may never know for certain, exploring these possibilities draws us closer to understanding not just the universe, but the very nature of existence itself. If we follow the thread of these ideas further, we find ourselves face to face with the possibility that the universe may not even need a beginning in the way we imagine. Some quantum cosmologists suggest that the universe could be self-contained, with no edge, no outside, and no before. In this framework, space and time curve back on themselves like the surface of a sphere, creating a reality that is finite yet without boundaries. Imagine standing on the surface of the Earth. You can travel in any direction and never encounter an edge, yet the Earth is not infinite. The same concept, applied to space and time, suggests a universe that simply is, requiring no moment of creation, no before. And still, others take a more spiritual or philosophical approach, suggesting that perhaps the universe is not only a physical structure, but also a reflection of consciousness itself. Some theories hint that consciousness and the cosmos are deeply intertwined, that reality may not exist without observers to perceive it. If so, then what came before the Big Bang might not just be a question of physics, but of awareness. In the end, whether we see the Big Bang as a beginning, a bounce, a bubble in a multiverse, or a timeless curve in spacetime, one truth remains. The universe we inhabit is far grander and more mysterious than we can fully comprehend. And perhaps that mystery is its greatest gift, calling us to wonder, to seek, and to imagine. Some physicists even suggest that the seeds of our universe could have come from a quantum fluctuation in a pre-existing vacuum, a kind of restless energy field where particles flicker in and out of existence. In this view, what we think of as nothingness is actually a foaming ocean of potential, and the Big Bang was a ripple that grew into the cosmos we know today. This quantum vacuum would not be empty at all, but buzzing with activity, governed by probabilities rather than certainties. One fluctuation might vanish instantly, another might expand just enough to spark a universe. Our reality could be the rare result of such a fluctuation taking hold and inflating into a cosmos filled with galaxies, stars, and life. Others imagine that universes could form the way bubbles do in boiling water, each emerging from the energy of the vacuum, expanding into its own realm of space and time. If so, then our universe may be one bubble among countless others, most of which we will never see. And perhaps, somewhere in that endless sea of bubbles, other beings are asking the very same question we are now. What existed before their beginning? No matter which possibility we explore, the deeper we look, the more we realize that the line between nothing and something is far thinner and more mysterious than we ever imagined. Another perspective comes from the idea of eternal inflation. According to this theory, inflation, the rapid expansion that shaped our early universe, may still be happening in distant regions beyond what we can observe. In this endless process, new universes constantly bud off from the inflating background, each beginning with its own Big Bang. Our universe would just be one bubble in this vast cosmic froth, with countless others continuing to form beyond our horizon. If eternal inflation is real, then the concept of a singular beginning may not apply at all. Instead, Creation is continuous, with universes endlessly giving birth to more universes. This shifts the question from what existed before the Big Bang to a broader mystery. What is the ultimate source of this eternal process, and why does it exist at all? Some scientists also consider that the laws of physics themselves might evolve across this multiversal landscape. Universes that cannot support stability may collapse quickly, while those with the right balance of forces continue to expand and thrive. If so, then the fact that we exist in a universe capable of sustaining life may not be a coincidence, but a natural outcome of this grand cosmic selection. Each of these ideas paints a picture of a reality without a simple beginning, a cosmos that may stretch infinitely both in space and in possibility. And while the answers remain out of reach, the very act of imagining them brings us closer to understanding the vastness of existence. There is also the concept of the cyclical universe, an idea suggesting that our cosmos undergoes infinite cycles of birth, death, and rebirth. In this scenario, the Big Bang was not the first beginning, but rather the latest in an endless chain of cosmic events. After expanding for billions of years, the universe could one day slow, contract, and collapse into a dense state, only to explode outward again in another Big Bang. This cycle of expansion and contraction, sometimes called the Big Bounce, hints that there was always a universe before ours, and there always will be another after. It transforms the idea of a single origin into an eternal rhythm, with each universe carrying traces of the one before. Interestingly, some modern theories attempt to find evidence of such cycles in the cosmic microwave background, the faint afterglow of the Big Bang. Tiny patterns in that ancient light might reveal scars or imprints left behind by previous universes. Though the evidence remains uncertain, the possibility suggests that our cosmos could be far older and more layered than we ever imagined. If true, it would mean that what we call the beginning is simply one note in an endless cosmic symphony, a melody that plays again and again across eternity. Another fascinating idea is rooted in string theory, where our universe may be just one of many three-dimensional membranes, or brains, floating in a higher dimensional space. According to this perspective, what we call the Big Bang could have been the result of two brains colliding, releasing immense energy and giving birth to the cosmos we know. In this picture, the true reality is not limited to the familiar three dimensions of space and one of time, but includes hidden dimensions beyond our perception. These dimensions may be tightly curled up, invisible to us, yet fundamental to the laws that govern everything. The collision of brains could have set the stage for our universe, while others continue to drift in this higher dimensional space, each with its own unique properties. What makes this theory especially intriguing is that it suggests our Big Bang was not the beginning of all existence, but rather a dramatic event within a much larger multiversal landscape. The cosmos we see might be just a small patch of a grander reality stretching far beyond our comprehension. If so, then before our Big Bang, there may have been other brains, other collisions, and other universes born in the same vast expanse, each carrying its own story, unfolding in silence beyond our reach. Some scientists take an even more radical approach, suggesting that time itself may not be fundamental. In this view, time could be an emergent property, something that arises only when the universe reaches a certain complexity. If that's the case, then asking what happened before the Big Bang might be like asking what's north of the North Pole. The question simply has no meaning. In this framework, the Big Bang wasn't just the beginning of matter and energy, but the dawn of time itself. Before that moment, there was no before, because there was no time for events to occur. Everything we know about cause and effect, past and future, only makes sense after the birth of time. This idea can be difficult to wrap our minds around because our entire experience is rooted in the flow of time. Yet physics suggests that on the deepest levels, the universe may not have a ticking clock at all. Instead, time could be an illusion created by the way we perceive change and sequence in a universe that, at its core, may exist all at once in a timeless state. If this is true, then the Big Bang was not just the start of the universe, but the unveiling of time itself, the very stage upon which all of history would unfold. Another perspective comes from the idea of a quantum origin of the universe. In quantum physics, uncertainty rules at the smallest scales, and particles can appear and vanish without warning. Some scientists propose that the universe itself may have sprung from such a quantum fluctuation, a spontaneous event where the energy of nothing blossomed into everything. In this view, what we call nothing is never truly empty. Instead, it's a restless sea of quantum fields, constantly flickering with potential. From this seething backdrop, a fluctuation could have provided the spark that ignited our universe. Unlike a traditional explosion, this wasn't an outward blast into space, but rather the sudden appearance of space and time themselves, expanding rapidly in a process known as inflation. What makes this idea so striking is that it suggests no external trigger was necessary. The laws of physics themselves, existing in this quantum realm, could have been enough to give rise to our universe. In that sense, the Big Bang wasn't a beginning in the way we imagine beginnings, but a transition from potential to reality, from possibility to presence. If correct, then before the Big Bang, there may not have been a void at all, but a quantum landscape filled with the seeds of countless possible universes, waiting for one to take hold and bloom into existence. There is also the hypothesis that the universe has no true beginning or end, but instead exists in a steady state of transformation. In this model, the cosmos is eternal, with regions constantly being renewed while others fade away. Rather than a single explosive origin, creation becomes a continuous process, always happening somewhere in some form. Some variations of this idea propose that black holes may play a role in seeding new universes. When matter collapses into a black hole, it may not simply vanish. Instead, the extreme conditions inside could give rise to a new bubble of space-time, budding off from our universe like a branch sprouting a leaf. From the outside, we see only the black hole, but on the inside, an entirely new cosmos could be unfolding. This paints a picture of reality as a vast, interconnected web, where universes are born within universes, each carrying the potential for entirely new laws of physics and new possibilities for existence. In this way, our Big Bang may have been the offspring of a parent universe, continuing an endless cycle of cosmic creation. If so, then asking what existed before our Big Bang may lead us not to a single answer, but to an infinite chain of origins, each universe giving birth to the next in a timeless cascade. Another line of thought comes from the concept of the multiverse, the idea that our universe is just one of countless others, each with its own unique set of physical laws and conditions. In this framework, the Big Bang was simply the moment our particular universe began. But beyond our cosmic horizon, other universes may exist simultaneously, each born from its own beginning. Some multiverse models suggest that these universes emerge from eternal inflation, a process where space itself expands endlessly, spawning bubble-like regions. Each bubble becomes its own universe, cut off from the rest by vast expanses of inflating space. In one bubble, the laws of physics might look like ours, while in another, they could be utterly different, shaping worlds we can hardly imagine. If the multiverse is real, then before our Big Bang, there may not have been nothing at all, but an endless, frothing ocean of universes in the making. Our cosmos would simply be one wave among many, a chapter in a much larger story that has no true beginning or end. This idea doesn't just expand our view of what came before. It suggests that the question itself might be too small because what we call the universe could be just a tiny corner of an infinite multiverse, each part with its own tale to tell. Some theories even suggest that our universe might one day collapse in on itself, only to be reborn in another Big Bang. This is known as a cyclic universe model. In this scenario, time doesn't run in a straight line from a beginning to an end, but in vast loops, with each universe giving rise to the next through an endless sequence of expansion and contraction. Imagine the cosmos breathing in and out on a scale far beyond human comprehension. Each cycle begins with a Big Bang, expands for billions of years, and then eventually slows, reverses, and collapses into a big crunch. From that collapse, the conditions may ignite yet another Big Bang, restarting the process. If this is the case, then what we call before the Big Bang might have been the end of a previous universe, its death giving birth to our own. Every galaxy, star, and planet we know could be part of a rhythm stretching across eternity, where beginnings and endings are not separate, but simply different phases of the same cosmic heartbeat. This vision of reality suggests that nothing is ever truly lost. Instead, the universe continually renews itself, carrying the echoes of past cycles into the future in an endless dance of destruction and creation. Another fascinating possibility comes from the idea that the Big Bang wasn't the absolute beginning, but rather a transition from a prior state of the cosmos. Some models describe a pre-Big Bang universe that was cold, dense, and perhaps governed by laws very different from the ones we know today. In these scenarios, the Big Bang could have been more like a phase change than a creation event. Imagine water turning into steam. Before the transformation, the water exists in one form. After, it exists in another. The Big Bang might have been the universe undergoing such a transformation, shifting from one state of being into the rapidly expanding cosmos we now inhabit. This approach doesn't require us to imagine nothing before the Big Bang. Instead, it paints a picture of a universe always in existence, but changing forms over time. What we call the beginning could have been a dramatic moment of transition, the point where the familiar laws of physics emerged from a hidden and mysterious prior reality. If so, then the Big Bang wasn't the start of everything, but the unveiling of the world as we know it, the moment when the curtain lifted on the cosmic play we find ourselves in today. There is also the concept of a timeless realm, a state where the usual flow of past, present, and future does not apply. According to some interpretations of quantum gravity and string theory, time itself may not have existed before the Big Bang. In this view, asking what came before is like asking what lies north of the North Pole. The question doesn't quite fit the reality. Here, the Big Bang represents not just the origin of space, but the birth of time itself. Without time, there was no before, no sequence of events, only a kind of timeless reality beyond our comprehension. In such a framework, the universe didn't arise from nothing, but from a realm where concepts like nothing and something simply don't apply. This idea may feel unsettling, because our minds are so used to thinking in terms of before and after, cause and effect. Yet physics suggests that time could be a feature of the universe that only appeared with the Big Bang, meaning the question of what existed beforehand may not have an answer in the way we expect. Instead, the beginning might mark the edge of time itself, a boundary beyond which the very notion of existence before ceases to make sense. Another perspective looks at quantum mechanics for answers. In the strange world of quantum physics, particles can flicker in and out of existence, borrowing energy from the vacuum before vanishing again. Some scientists believe the universe itself could have emerged from such a quantum fluctuation. In this scenario, the cosmos began not from nothing, but from a seething quantum vacuum, a state filled with potential energy. This vacuum isn't empty. It's a restless stage where the laws of probability allow for the spontaneous creation of entire universes. Our Big Bang, then, might have been the moment one such fluctuation grew large enough to ignite the expansion of space and time. It's a concept that challenges our intuition because it suggests that even what we call nothing is never truly empty. Instead, it's a vibrant sea of possibilities where the birth of a universe is not impossible, but perhaps inevitable. If this view is correct, then the Big Bang was not a unique miracle, but a natural unfolding of the quantum fabric, one ripple in an infinite ocean of potential reality. Some thinkers have also proposed that our universe could be the result of a collision between higher dimensional structures. In certain versions of string theory, what we perceive as our universe may actually be a three-dimensional brain floating in a higher dimensional space. According to this idea, the Big Bang could have been triggered when two such brains collided. The immense energy released in the impact might have ignited the rapid expansion of space and time, giving rise to everything we see today. This model doesn't just describe a beginning. It implies that other brains may still exist, parallel to ours, perhaps carrying their own universes with their own stars, galaxies, and laws of physics. These other realms would be invisible to us, separated by dimensions we cannot yet perceive, but close enough that a collision could someday happen again. If true, the Big Bang was less a solitary event and more a cosmic interaction, a spark struck between vast, unseen realities. It hints that our universe may be one among many, born not in isolation, but from a grander, multidimensional stage. There's also the intriguing idea of an eternal inflation model. In this picture, the universe is part of a vast multiverse, an endless expanse where inflation, an incredibly rapid expansion of space, never truly stops. Within this sea of inflation, countless bubble universes are constantly forming. Each bubble begins with its own Big Bang, expanding and cooling into a cosmos with its own properties and physical laws. Our universe is thought to be just one such bubble, floating among an infinite number of others. In this framework, asking what existed before our Big Bang is like asking what's outside your own bubble. The answer could be more bubbles, each one with its own unique version of reality. Some might be similar to ours, with stars and galaxies. Others could be so different that the very rules of physics we rely on would not apply. If eternal inflation is real, then the Big Bang wasn't the beginning of everything, but simply the beginning of our bubble, one pocket in an infinite cosmic froth. Another compelling idea is the cyclic universe model. Instead of a single beginning, this theory suggests that the cosmos goes through endless cycles of birth, expansion, collapse, and rebirth. In this vision, the Big Bang wasn't the first explosion, but simply the latest chapter in an infinite story. Imagine the universe as a cosmic heartbeat. It expands for billions of years, then slows, contracts, and eventually collapses in what's called a big crunch. From that collapse, the conditions may once again ignite a new Big Bang, beginning the cycle all over again. If this is the case, then what existed before our Big Bang was another universe, different yet connected, whose death gave birth to ours. It would mean there was never truly a beginning, just an eternal rhythm of destruction and creation, like a phoenix rising from its ashes again and again. This model suggests that the story of existence is infinite, without a first page, and that the universe we know is one in an endless line of universes stretching backward and forward through eternity. Some scientists also explore the idea that before the Big Bang, the universe existed in a state known as a singularity, not just a point of infinite density, but a realm where the familiar laws of physics completely break down. In this state, concepts like space, time, and even causality lose their meaning. In this view, the singularity wasn't a thing in space. It was the raw, formless essence from which space and time themselves emerged. The Big Bang, then, was less an explosion and more a transformation, a shift from a realm beyond comprehension into the structured universe we inhabit today. It's difficult for the human mind to picture such a state because all our experiences are tied to space and time. But if physics is correct, the singularity was a condition outside those boundaries, where the universe's destiny was encoded in a way we may never fully understand. This perspective frames the Big Bang not as the start of everything, but as the moment order arose from an indescribable foundation, setting into motion the cosmos that would one day give rise to galaxies, stars, planets, and life. Another possibility comes from the idea that the universe has no true beginning at all. Some physicists propose that time itself may be infinite, stretching endlessly into the past as well as the future. In this scenario, the Big Bang wasn't the start, but rather a transition, a change in the universe's state, like water freezing into ice or steam condensing into droplets. Before the Big Bang, the universe might have existed in a different form, perhaps dense and static, or spread thin and diffuse. Then, under the right conditions, it transformed, igniting the rapid expansion that became our cosmos. If time really is infinite, then asking what came before the Big Bang is a bit like asking what lies north of the North Pole. The question itself may lose meaning, because the framework of time as we understand it may not apply before that transition. This idea suggests that the universe has always been, shifting from one state to another, with the Big Bang simply marking the beginning of the chapter we currently inhabit. There's also the fascinating suggestion that the laws of physics themselves may evolve across different universes. Some theories propose that new universes are born through processes that slightly alter the rules governing them, like variations passed down through cosmic generations. In this view, our Big Bang might have been not just the birth of space and time, but also the creation of a unique set of physical laws. The strengths of forces, the masses of particles, even the number of dimensions could have been determined in that instant. This could mean that before our universe, others existed with different laws entirely, some too chaotic to form stars, others perhaps unable to sustain matter as we know it. Ours may be one of the rare universes where the conditions aligned just right for galaxies, planets, and eventually life. If true, the Big Bang was not only a beginning but also a roll of the cosmic dice, shaping the very framework of existence we now depend on. Another perspective considers the role of quantum mechanics. At the smallest scales, reality doesn't behave in smooth, predictable ways, but instead flickers with uncertainty and possibility. Some scientists believe the universe may have sprung from a quantum fluctuation, a spontaneous emergence from what's called the quantum vacuum. Unlike the vacuum of empty space, this vacuum isn't truly nothing. It's a restless sea of potential, filled with fleeting energy that can momentarily give rise to particles before they vanish again. In rare cases, a fluctuation might be powerful enough to trigger the birth of an entire universe. In this picture, before the Big Bang, there wasn't absolute nothingness. There was a deep quantum field buzzing with hidden energy. Out of this, our universe could have appeared, expanding rapidly and forming everything we know today. It suggests that creation may not require a cause in the way we usually imagine, but could instead arise naturally from the fundamental uncertainty woven into the fabric of reality itself. Some researchers also explore the idea of a universe born from higher dimensions. According to certain versions of string theory, our cosmos may be just one three-dimensional membrane, or brain, floating within a higher dimensional space. In this scenario, the Big Bang might have been the result of two brains colliding. The immense energy released in such a cosmic collision could ignite the birth of a new universe, with its own space, time, and physical laws. If this model is correct, then before the Big Bang, there wasn't an empty void but a higher dimensional reality where vast brains drifted and occasionally intersected. Our universe would be one of many, each formed when such collisions occurred. This idea opens the door to a reality where countless other universes might exist alongside ours, hidden in dimensions beyond our perception, their presence only hinted at through the mathematics of advanced physics. Another idea is that what we call the Big Bang may have been the end of something rather than the start. Some cosmologists suggest that our universe could be the rebirth of a much older one that collapsed in on itself. This collapse, often described as a big crunch, would have compressed everything into a state of extreme density, setting the stage for a new expansion. In this vision, the Big Bang was not a singular beginning but a handoff between cosmic ages. The universe breathes in and out, expansion followed by contraction, followed again by expansion, in a cycle that could continue indefinitely. If this is true, then the universe before ours may have looked entirely different, with its own galaxies, stars, and even forms of life. None of it would have survived the transition intact, but its energy and matter could have become the seeds of our cosmos, carried forward into this cycle. Such a model paints. Some theories even suggest that the Big Bang might not have been the start of everything, but a transition from a state dominated by pure energy. In this view, before there were galaxies, stars, or even atoms, there was only an immense field of energy, uniform and featureless. Over time, tiny fluctuations within that energy field could have sparked the rapid expansion we call the Big Bang. These ripples, though incredibly small, eventually grew into the vast cosmic structures we see today: galaxies, clusters, and the web of the universe itself. This idea paints the early pre-Big Bang state as not a void, but a kind of primordial ocean of energy, waiting for the right conditions to unleash creation. From that sea of potential, space and time themselves could have crystallized, giving rise to the universe we now inhabit. If this is true, then the question shifts from what existed before the Big Bang to what was the nature of that timeless energy field, and why did it blossom into the cosmos we know? Another perspective considers quantum mechanics, where the concept of nothing isn't really empty at all. According to quantum theory, even in a perfect vacuum, energy constantly flickers in and out of existence in the form of virtual particles. Some scientists suggest that our entire universe could have emerged from such a quantum fluctuation. In this picture, what we think of as nothing is actually a seething quantum foam filled with possibilities. One of those possibilities was the spark that expanded into everything we know. What makes this especially intriguing is that the laws of physics themselves might allow a universe to arise spontaneously, without the need for an external cause. Energy borrowed from the vacuum could have fueled the Big Bang, balanced perfectly by the gravitational energy pulling everything together, resulting in a universe whose total energy adds up to zero. In that sense, before the Big Bang, there may not have been true emptiness but a restless quantum sea, endlessly bubbling with potential until one fluctuation grew large enough to ignite a universe. There are also ideas drawn from string theory and its extension, M theory, which suggest that our universe might be just one three-dimensional brain floating in a higher dimensional space. In this scenario, what we call the Big Bang could have been the result of two such brains colliding. The immense energy of that collision would have ignited the birth of our universe, creating the expansion and matter we see today. If true, then before our Big Bang, there was a vast higher dimensional reality where brains drifted and occasionally touched, each collision giving rise to a new universe. This would mean our cosmos is not unique, but one of many, all arising from the same higher dimensional stage. It is a concept that not only explains what may have come before, but also suggests that the process might continue, with new universes forming from future collisions in realms far beyond our own. Some scientists explore the possibility that time itself might be cyclical. In this view, the Big Bang was not the first beginning, but just the latest in an endless series of cosmic rebirths. According to these cyclic models, the universe expands for billions of years, then eventually slows, contracts, and collapses in a big crunch. From that collapse, a new Big Bang could ignite, beginning the cycle all over again. Each cycle would erase the traces of the one before it, but the overall pattern would continue forever. Birth, growth, decline, and rebirth, like the heartbeat of the cosmos. If this is the case, then before our Big Bang there was not nothingness, but another universe living out its final moments, paving the way for the one we now call home. Another fascinating theory comes from the idea of a quantum bounce. Instead of the universe collapsing completely in a big crunch, quantum effects could prevent it from shrinking to a single point. In this model, as the universe contracts and reaches extreme densities, quantum physics steps in to halt the collapse, causing it to rebound outward in a new expansion, our Big Bang. This means the Big Bang wasn't the beginning at all, but rather a bounce from a previous universe that had collapsed. The cosmos could therefore be eternal, endlessly contracting and expanding, with each bounce giving rise to a new chapter of existence. In this picture, before our Big Bang was a universe much like ours, living out its life until the cycle turned, and the next great expansion began. Another line of thought comes from the multiverse hypothesis, which suggests that our universe is just one bubble in an endless cosmic sea. According to this idea, before the Big Bang, there may have already been countless other universes forming, expanding, and perhaps even fading away. In this scenario, our Big Bang was simply the moment our particular bubble inflated out of that larger multiverse. Each universe could have its own physical laws, its own constants, and even its own form of matter and energy. If the multiverse is real, then the Big Bang wasn't the beginning of everything, only the beginning of our local universe. Beyond our cosmic horizon, there could be infinite other universes, some still being born while others have already ended. This perspective transforms the question from what existed before the Big Bang to what kind of multiverse landscape do we belong to, and how many other realities exist alongside ours. Some theories even blend quantum mechanics with cosmology to propose that the universe could have emerged from a timeless, spaceless quantum state. In this view, the universe began not with a bang, but with a quantum transition, a sort of leap from possibility into reality. One such idea is the Hartle-Hawking no-boundary proposal. It suggests that the universe didn't have a sharp beginning. Instead, time itself may have behaved more like space at the very start, gradually transforming into the familiar flow we experience today. In that earliest moment, the universe might have been smooth, finite, and curved, without edges or boundaries. There was no before, only a timeless quantum state from which space and time emerged like ripples from a still pond. This theory paints a quiet, almost serene origin for the cosmos. No explosion, no chaos, just a gentle unfolding from pure potential into a universe filled with stars, galaxies, and eventually us. Another perspective considers the role of vacuum energy, the restless sea of quantum fluctuations that fills even the emptiest parts of space. Some scientists suggest that before the Big Bang, the universe may have existed in a kind of false vacuum, a high-energy state waiting to decay. When that vacuum finally shifted into a lower-energy state, it could have triggered a sudden burst of inflation, creating the Big Bang and the universe we now inhabit. This picture makes the origin of everything less like an absolute beginning and more like a transition, a phase change, similar to water freezing into ice or boiling into steam. If true, then before our Big Bang was a strange, invisible ocean of quantum energy, silent and formless, holding within it the potential for everything we know. When the shift came, that hidden energy unfurled into space, time, matter, and light, setting the stage for the cosmic story we are still part of today. There's also the intriguing idea of higher dimensions. Some cosmologists propose that our universe is like a three-dimensional membrane, or brain, floating within a larger multi-dimensional space. In this framework, what we call the Big Bang might have been caused by the collision of our brain with another one. The enormous release of energy from such a collision could have ignited the expansion of space, giving birth to our universe. If this is the case, then before the Big Bang, there may have been an entire higher dimensional landscape, with brains drifting, colliding, and separating, each encounter creating new universes. It suggests that our cosmos is not isolated, but part of a grander, unseen architecture, where whole universes might be constantly forming in the vastness beyond our perception. And so, when we ask what existed before the Big Bang, we find ourselves at the edge of both science and imagination. Some theories suggest there was nothing at all, because time itself began with that moment. Others point to timeless quantum states, infinite cycles of expansion and contraction, or vast multiverses filled with countless other realities. Each possibility stretches our understanding a little further, reminding us that the universe is far more mysterious than we can easily comprehend. What's certain is that the Big Bang was not just a beginning. It was the start of our story, the opening chapter of everything we see and know. And though we may never fully uncover what came before, the very act of wondering connects us to the deepest truths about existence. So as you settle your thoughts tonight,